I'm Dan Jeffries, Managing Director of the AI Infrastructure Alliance, and welcome to the age of industrialized AI. It's 2033, and you're a top-notch concept artist in London, building a game with 100 other people. Game looks incredible, absolutely incredible. It's powered by Unreal Engine 9, and it's capable of photorealistic graphics in real time on the PlayStation 7 and near perfect physics. It's got a character AI that can talk with anyone in an open-ended way and still stay within the plot guidelines to keep players hunting down those magical rubies and the divine sword of radiance. 10 years ago, it would have taken a team of 1,500 to 5,000 people to make this giant game. And now you can do it with 100 people. But that doesn't mean less work. It doesn't mean artists are out of business. There's more artists than ever. There's more business than ever, a lot more. We used to get 10 AAA games a year, and now we get 1,000. As the lead artist, you've already created a number of sketches with a unique style for the game. Your executive creative director and the environment designer signed off on it, and you fed that style to a fine tuner of a foundation model. And the AI model can now rapidly craft the assets that share that look and feel. Art is not dead. It's just become co-collaborative with intelligent agents. Now you can move a lot faster. You quickly paint an undersketched battle robot for the game, plus a bunch of variants you were dreaming about last night. You feed it into your artist workflow and you talk to it. And the large language model behind it is able to understand what you want. You say you want 100 iterations and 20 different poses, and it starts to spit them out. And in 2 seconds later, high resolution. You start flipping through them, just gesturing through them. You see the 27th one looks amazing. So you snatch it out of that workflow. You throw it in a concept painter, and you quickly add some flourishes, different face masks that the generative engine didn't quite get right. A new wrist rocket. You erase that laser shoulder cannon, and you're inspired. So you place it with an energy rifle and you feed it back into the engine. You fix a few problems and now it's good to go. So you send it off to the automatic 3D transform and it pops out in the 3D artist workflow, fully formed a few minutes later. The 3D artist working from Chiang Mai, Thailand, has to fix a few mangled fingers and some clothing bits that don't quite flow right. And then it's ready to go and he kicks it off to the story writer working out of Poland. And seeing the new character gets her inspired. She quickly knocks out a story outline in the meta story language and feeds it to her story iterator. It generates 50 completed versions of the story in a few seconds. But she's not out of business either because it's not a perfect rewrite. So she starts to look at them and it looks good, but it needs a little work. One of the sub characters isn't great. So she rewrites the middle, weaves in a love story over the next couple of days with one of the characters and feeds it back into the engine for cleanup. The new draft comes back and it reads so well that she fires it off to the animators in New York City. Welcome to the age of industrialized AI. But how did we get here? Let's roll back the clock a little bit to the current day. 2023, we saw the Great Ravine. It was a great acceleration of AI because this whole great acceleration of AI started with a collapse. In 2023, we saw a big collapse in consolidation around MLOps companies. You see, all these MLOps companies that had come out are working at this sort of low level, and they had all figured that it wouldn't be long before every company in the world had a small army of ML engineers cranking out models. There's just one problem. It didn't happen. And why didn't it happen? Well, they forgot one thing. Real machine learning is incredibly hard. You know, it's one thing to do some churn prediction and some tabular data work, but if doing machine learning itself, it's a massive amount of data that can't be labeled with brute force, millions of dollars worth of GPU compute, and a lot talented and very, very expensive people. In short, it's just too complicated and too expensive for the average company to build out a supercomputer, hire an ML team, a data team, an MLOps team, and build a top-of-the-line model. Most companies will never train advanced AI from scratch. The vast majority of companies won't even interact with AI at this low level. If you think about them, all the companies are basically doing all this huge amount of steps that are involved in creating these models, ingesting the data versioning, lineage, ingesting the files, labeling them both programmatically and manually, doing experiments, distributed training, packaging up the model, deploying it, optimizing it, doing inference at scale, monitoring and management. This is essentially like writing assembler. It's essential for a small subset of tasks, which is way too complicated for most projects. Most companies are just not going to have the time or the money or the people power to do all of these things. So we're going to see a lot of mergers, acquisitions, fire sales, flameouts this year. We call that the Great Ravine. And it's already started to happen. I've already seen it in my own experience. Many companies are not going to cross that chasm. Right? You know, the old business book, Crossing the Chasm. But that's all right, because the ones that do will get stronger. And in the end, we're going to have a canonical stack of AI. You can think of it as the LAMP stack for artificial intelligence. And once we had a LAMP stack, we got WordPress. Once we got WordPress, we get high-level drag and drop editors like Divi that make it easy for anyone to design a cool-looking website. And that's really exciting. In fact, the entire history of technology is abstracting up the stack. If you think about it, each level of abstraction makes it easier for more people to get involved in it. It doesn't mean actually that the domain experts are sometimes worried they're going to be gone or out of a job. They're not. You still need that awesome CSS editor and somebody who can have precise precision in terms of crafting a website for the very advanced websites, the enterprise websites. But if you're just a marketer, you want to get a squeeze page knocked out, or you want to knock out a web page for your book, having a higher level of abstraction makes it a ton easier. And the same thing is going to be true for artificial intelligence. Most people are just not going to be interacting with it, at that very low level. They're going to be abstracting up the stack, and that's going to bring in more kinds of people, which is going to accelerate artificial intelligence and AI-driven businesses. So what's going to happen also is all these MLOps companies are going to start to serve a couple of different kinds of companies. They're either going to serve kind of the citizen data scientist kinds of things, the churn predictions and those kinds of things, or if they're going to be doing hardcore machine learning, they're going to be serving two kinds of companies: AI-driven businesses and foundation model companies. So let's talk about those. At the core of all this and the rise of the foundation, right, is AI-driven businesses are companies where the business model simply cannot exist without artificial intelligence. Okay, if you take something like Boeing, they might have machine learning in 5 different aspects of their business, maybe material science, maybe testing the wind drag and all these kinds of things. But their main business is making airplanes. If you have an AI-driven business, it is a business where the entire business model is built around artificial intelligence and machine learning. So if you take something like photorealistic people generation, if I'm generating photorealistic people and all kinds of like races, ethnicities, and shapes and sizes, and from all over the world, and I am generating them so that an online fashion catalog can show 1 million different clothes combinations in all their different permutations, you'd never be able to hire enough people to go ahead and show all those permutations on the different body types and the different ethnicities and stuff that folks want to see them in. But you could do that with artificial intelligence. And you're still going to hire the people to go do the big photo shoot, the big hero shoot, as they call it in the industry. So that is an AI-driven business. It's one where the model is based entirely around artificial intelligence at its core. Those companies are going to be served by that. The other ones are going to be the foundation model companies. We've already talked a bit about those. The foundation model companies are the ones that essentially are building those gigantic foundation models. You think about things like Stable Diffusion, ChatGPT, Open Whisper, all these kinds of things that are out there that are capable of being fine-tuned and doing all kinds of incredible different things, from like logic to natural language to generating images, et cetera. So we're going to see thousands of kinds of AI-driven businesses in the coming years doing things that are totally impossible with regular code. You can expect to see personalized music or hit generators, on-the-fly video editors, rapid concept designers that can go from image to 3D assets in the blink of an eye, custom drug designers for diseases that were too small to warrant R&D in the past, advertising, stock photo creators, so much more. We're only beginning to understand what we can do with these powerful models. And if coders and hobbyists everywhere get their hands on them, entrepreneurs, et cetera, get their hands on them for the very first time, they'll come up with applications that no single company can imagine on their own. I've seen it with things like Stable Diffusion, where people are suddenly using images to come up with ways to generate music or to generate synthetic brain scans for doing medical research. These kinds of things are incredible, and the original designers are never able to think of them until they kind of get out of the cage. So we talked already a bit about the foundation model companies, but again, these are the companies that are dedicated to building out those most cutting edge models in the world, the foundation models. They're big, they're powerful, they're incredibly expensive to train. You got companies like Microsoft, Google, Amazon, OpenAI, Stability AI, Jasper, Midjourney. They're just the beginning. Now, it's incredible. You're going to see more and more of these companies. Some of these companies Right now, Microsoft and Google are the big, 24, the 80,000-pound gorillas in the building. But the thing is, the next Amazons and Googles and Microsoft, this is a turning point, an inflection point. They're being baked right now. They're going to be the ones in the S&P 500 in 20 years. And they're probably not going to be the old tech companies. Those old tech companies are always going to be competitive. They're always going to be around. But they have the innovator's dilemma where they have to protect the old business model. And a lot of the new companies are going to come along and they're not going to care about the old business model. They're going to be able to innovate in a brand new way. So I expect these to see some brand new mega tech companies that are artificial intelligence companies in the next 10 years and then coming to the top of the front after that. So as we said earlier, these massive models are simply out of the reach for most companies, right? They're not going to hire all the researchers and label a petabyte of data. And they're not building out supercomputer clusters with things like the NVIDIA A100s or H100s, or each card, $20,000 retail. And that's just to get started. You have to keep investing in the hardware to keep building these models, which means supercomputers that get swapped out every year or two. Competition for these advanced chips is going to be incredibly fierce among companies and nation states. And that takes us to the next big factor in the next decade, the chip wars. What are the chip wars? Right now, China and the United States are vying for world AI chip domination, and there are other nations that are out there eyeing the chance at this inflection point as well. You have to understand that microchips are everything from our cars, our phones, our computers. We rarely think about all the things that they're in. Our most advanced military systems, they're key to our medical equipment, to tractors even, and vacuums. In short, every major modern convenience and tool. China spent more on semiconductors than it did on oil in 2020, buying $350 billion worth of chips. There's already been a bunch of books on this. There's going to be more. Expect to see it. Chinese leadership sees it as a historical chance to leapfrog the US and take pole position on the world stage. And they're right. Whoever wins at AI sets the stage for the next century, certainly for the next several decades. And then why do these chip wars exist, though? This is important to understand. Apple, Google, Amazon, Tesla, NVIDIA, they're all designing their own chips, but they make exactly 0 of them. That is the province of a company called Taiwan Semiconductor. It is the most powerful semiconductor manufacturer in the world. Taiwan Semiconductor is an irreplaceable corporation. In Taiwan, it's fed by a global network of irreplaceable companies in Germany, the US, Netherlands, Japan, and Korea. So how do we get this way? How do we get to the small subset of companies that are making all of the chips in the world? And when I say everything, take for example, one Dutch company called ASML. It makes 100% of the world's extreme ultraviolet lithography machines, the UAV machines. They're the only company in the world that can make them. And each unit costs $100 million. And the next generation ones that are coming cost $300 million in 2025. Now, that right there is the key. Each one of these advanced fabs costs $20 billion or more to put into production. So ASML was an investment from Intel and a bunch of other companies in Korea and Japan and everywhere else to build these extreme ultraviolet machines. Basically, when you think about how chips are made, they're basically made by shining light over a pattern and then essentially etches it in to the silicon wafer. The frequency of light is the limiter on how small you can make those chips. And so this is incredibly advanced R&D research. Took something like 20 years of investment, and many companies weren't even sure that could ever be done, that you could use extreme ultraviolet lithography to make these chips super, super small. And so they invested in ASML, and ASML can't make these chips on their own. They're all fed by these other companies that make critical components, and there's maybe only one company in the world. You have to specialize in this. It's incredibly expensive to do, and it's why you have this sort of global supply chain, and people are looking to try to reset that supply chain now. Right? You have Taiwan Semiconductor producing 90% of the world's most advanced chips. Think about that for a second. 40% of the less advanced chips that power everything from your toaster to your car, to the router in your house, to your desktop computer. Now, with China saber rattling and poised to take Taiwan back by any means necessary, that forced the U.S. and its allies to try to reignite homegrown fabs, which all outsourced. This is what happened. It used to be Companies like Intel had all their own fabs. They're still one of the only ones that do, but most of the rest of the world just outsourced it. It meant that you could build more chips, but it also meant that now the supply chain is basically dependent upon other things. So the US has also taken dramatic steps. They basically stopped NVIDIA from selling its most advanced chips to China to try to slow it down. The Economist calls Taiwan the most dangerous place in the world because an invasion there from the mainland would potentially smash the world economy in an instant. So the Chinese, though, they're not sitting still. They've got a flurry of companies looking to beat NVIDIA and make the most powerful chips at home. In the first 5 months, 2021, they had 164 companies they were supporting with 40 billion yuan. And so the blockade is likely to turbocharge the Chinese investment in homegrown chips. And it looks like it's already happening. The Chinese announced a package of $143 billion of investment in chips as a response to the US CHIPS Act of $280 billion, Chips and Science Act, to try to reignite these homegrown farms. So what's all at stake here is they're trying to, everyone in the world senses this inflection point, senses a chance to try to leapfrog and become the dominant player in artificial intelligence over the next decade or longer, the next century. In the end, there is no winning this war. There's no winning it. But breakthroughs in faster and smaller chips are always going to lead to mega advances for any nation that develops the technology first. It's a battle that will rage for, like I said, decades, if not centuries. And then it's not even limited to classic electronic transistor-based chips. As we move beyond them to photonic chips and beyond silicon to graphene and other biological materials, where it's only going to heat up. And each new breakthrough in chip architecture offers another country or company, or set of companies and countries, a chance to race to that front of the pack, a chance to become the center of the chips world and the center of an intelligence economy. And what does all that get us, right? The global chip war for AI supremacy between China and the US, new kinds of chips proliferating, the consolidation of MLOps companies into a lamp stack for AI, coming burst of dedicated training and inferencing powerhouses, the rise of AI-driven businesses and foundation models as a service, all mean one thing: the age of industrialized AI. Now, the spark is already lit, and we're on the verge of an incredible set of companies that are going to come out. And capabilities, if we think about this. A lot of people think about this as, we have to get to something like artificial general intelligence. We tend to think of intelligence as human intelligence. We don't need that. We have narrow intelligence now, and those are going to get very, very smart. Think about something like a squirrel. You might not think of a squirrel as intelligence, but you try to keep it out of your garden, and I guarantee you're going to see how smart that it is because it's optimized for getting into your garden. Try to keep the ants out of your house and getting to the sugar in your cabinet. You're going to see that those ants are optimized for getting in there. So those are narrow range intelligences, and we're going to continue to build a ton of applications that are able to do all kinds of things, and you're going to start to chain together. And what we're going to see is this verge of a brand new set of workflows and ways of interacting with software, and AI essentially becoming an interface to the world. So take something like ChatGPT. It only took a few days before people started using it for prompts in Midjourney, Stable Diffusion, chaining together AI apps into a new kind of workflow. And so what we're going to have is this infinite regress of AI working with AI. So ChatGPT is generating the prompts, and then they're knocking out these images, which are amazing. You can think of it as kind of a Zapier on steroid. Plug a bunch of traditional apps together with AI into an amazing and powerful set of never-before-seen apps. It's AI on top of AI on top of AI. It turtles all the way down, right? When you think about this, it's something like, imagine that I've got a data set of images, images of different poses of various people and sort of in their undersketch poses, and I'm feeding that to a model that's generating images. And I have another model and a piece of code that's checking those images to make sure they're aesthetically pleasing and they're not Cronenbergs and messed up. If they're Cronenbergs, it maybe deletes them, and the code sends it back to generate more images to replace those, maybe selectively modifying the prompt. And if they're completed images, it sends it off to another model that's going to go ahead and upscale it, that's going to do face correction like a GAN, or maybe another model that's going to do hand correction, right? And it's going to be feeding this all the way down, right? And that's the way that these things are going to work. And you're consuming these applications. I saw a wonderful one where an artist had trained the model to do turnarounds. Turnarounds are when I paint an amazing character. That's the fun part of art. But then I finish that character, and I have to now paint that character and the same character 10 different angles. That's the boring part. Someone fine-tuned a stable diffusion model star turner basically to do these kinds of models. So you're going to see these kinds of things consumed. It's turtles all the way down with AI interacting with AI. You're going to see AI defending AI. You see all the people trying to exploit ChatGPT or Bing, find ways around its, its guardrails, attack its logic. There's going to be new attack surfaces. And all of a sudden, you have other models looking for these kind of attacks, these logic attacks, and trying to shut down that interaction. So it's going to be a new kind of arms race, and it's going to be fantastic. So I had ChatGPT create a story for me about a biopunk soldier and his mech facing off against an alien invasion, a science fiction story. I've been a science fiction writer for a long time. And so he gave me key scenes. I said, give me some of these key scenes. So he gave me stuff like the biopunk soldier stands atop a crumbling city skyline, his combat mech powering behind him as he readies his weapon for the approaching alien horde. And so I put these as prompts into Midjourney, sort of diffusion, and Midjourney spit out these ones that said, and I added a bunch of things like extremely detailed, high quality, aka hyper realistic studio lighting, and it came out like this. It gave me back these beautiful images. Look at these things; they're incredible, right? And an artist will be able to even take these and do incredible things with it, erase the errors and do new iterations. It's incredible. So there's going to be 4 keys to the technologies for tomorrow. And there's maybe more than this, but 4 that I'm going to focus on as to how we kind of get into the supercharged set of narrow artificial intelligence things. So these things are where the foundation model companies and the key machine learning folks are probably going to focus over the next decade. Now, there'll be new techniques that potentially come out. It's, you can't see all the techniques ahead of time. For instance, I can't imagine the web browser. Nobody can imagine the web browser and a graphic designer before the internet exists and before computers exist, et cetera. So there could be some folks out there with working on a whiteboard to figure out a brand new way of teaching artificial intelligence that nobody's thought of before that would completely change the vector here. But if we look at these 4 technologies right now, I think these are the ones that have the biggest capacity. They're scale, search, reinforcement learning, and continual learning. So the first 2 techniques come to us from an article called The Bitter Lesson by an essay by AI researcher Richard Sutton. And the bitter lesson is simple. The only 2 things that have ever really worked in AI are scale and search. And what does that mean? Scale is like scaling up the technology so that people are able to kind of just generate lots of GPUs or specialized hardware and search, right? And every time there's a sort of an old joke that every time you fire a linguist, the large language model gets better, right? The linguist model gets better. And that's because, humans, we tend to really resist this concept. We react bitterly to it. We resent it because we like to think of ourselves as super special. It feels too much like blind evolution to just keep scaling up the GPUs, keep scaling up its search capabilities. So ironically, I think every researcher believes in a kind of intelligent design and the unique nature of the human mind. So this capacity of adding kind of human tweaking and code to it and concepts to it usually works in the beginning, and it's usually more intriguing to the researcher to do this, and rather than just jamming together a lot of neurons and letting it grind, it just feels downright barbaric. But it is the thing that works again and again and again, and we overly resist it. The foundation model companies and the truly successful companies are no longer going to resist this over the next decade. And when you think about what this has been able to do, the version of AlphaGo that beat Lisa Dahl was basically nothing but scale and search. It learned from millions of human games, and for billions and millions of human games and billions of games, it played itself. It played against itself, and now had this huge database of ideas that it could search through to guide its decision. It also had a ton of compute, right? That's the scale, and the search is the big database that it had. That was all it needed. And the later version, AlphaGo Zero, was smashed. The original AlphaGo that smashed Lisa Dahl didn't even learn from human games at all. It learned from playing itself over 70 days, and in the process figured out ways to win that no human had ever considered. No move had ever been played in that capacity in 2,500 years of play. Imagine that. Think about that. 2,500 years. Billions of people playing this game. No one had ever thought of these things. So this is the kind of creativity that AlphaGo Zero created. And if you don't think that it's created, you don't really know much about it, because now people study those games, right? The grandmasters study those games. But there's still hope for us yet. The artists and the AI engineers might be right. There is something special to the human spirit that we can give to the process, and that is reinforcement learning. Reinforcement learning become more and more essential for keeping our AI on the rails. It's a bit like how we train pets and children. We think of it as a reward punishment for AI. Right? This is where you're basically guiding its prompt over time. You're fine-tuning it with people's feedback over time. You're changing how it works. They have the constitutional AI that people were talking, that one of the big firms was talking about recently, where they kind of trained it, the model to kind of, whether it was fitting that constitution and then feeding that back into another model that retrained it, right, to get closer to the alignment that it wanted, right? So this kind of constant thing, when people were sort of gleefully pointing out how ChatGPT was stupid and it made big mistakes, and like we're getting around the guardrails and getting it to launch virtual machines and search the web when it wasn't supposed to. These are logic attacks, but what the joke was on everybody else, because we were all part of the distributed QA team for OpenAI. And so they were learning from all these things, basically, and they were basically making those rules smarter. So there's kind of a sociological level human feedback, and then there's kind of specific reinforcement learning where it's constantly training the model on the fly. And lastly, so we got scale, search, and RL. The last one I feel is going to make the biggest difference in that. And that's once researchers crack the problem of continual learning. And I talked about this in the coming age of generalized AI. This is where the model overcomes catastrophic forgetting. So what is that? Catastrophic forgetting is that when you teach a model something totally new, it remembers everything. It remembers everything it learned from the past, but it doesn't remember. It forgets everything. It forgets everything that it learned from the past. It slides incorrect there. So if I train a model essentially to recognize dogs in pictures, and then I go teach it to learn about how to recognize cats, it's going to forget everything that it knows about dogs. So continual learning is different, right? It's different than fine tuning. With a massive foundation model like Stable Diffusion, you can fine tune it. You can go add a bunch of cars or animate capabilities to it, or a particular art style, or photorealism, people that you want to, but you can only take it so far, because eventually fine tuning destroys the model. You can only really tweak the model with fine tuning. But continual learning has huge implications, because it's overcoming the ability to teach it something new. So you start to imagine like a robot that is a master of an entire domain. It can learn to do the dishes, and then maybe that capacity is stored in another, larger model. The information is compressed up in a subset of neurons. It's passed back to the other neurons in a bigger model, and then it learns new things from kind of its active learning neurons, right? And it keeps stacking those together. So now I can do the dishes and fold clothes and take the dog for the walk. So this model quickly becomes a master of a single domain. This is going to become incredibly powerful for companies in the future. And it has huge implications for every kind of AI, because it's going to make them smarter and more generalized over time. Now, a lot of AI research companies started with this focus on building safe and powerful AGI, artificial general intelligence, the golden, ticket, the goal of all folks. But no company is going to get to AGI by raising a few $1 billion and then starting there. We're going to need new techniques, new algorithms, better data, faster chips, software systems to support the models, and more. We're going to get to AGI when companies shift their focus to industrializing the capabilities of the models we can build right now, and to improving those capabilities, these narrow intelligence, these co-collaborative intelligences, these squirrel-level intelligences. When the industry is worth hundreds of billions or even trillions of dollars, we've maxed out the best business model for funding mega supercomputers. Is when we get something closer to this generalized AI, then maybe AGI. But we don't even really need to do amazing, awesome things, incredible things that we can do right now. People sometimes worry if I don't have R2D2 or C3PO or these kinds of things. We don't need any of that. And in fact, AI is much more controllable when it's narrow AI. So we want to focus on these things. We want to focus on the co-collaborative. And the other thing is, we're going to have to get comfortable with imperfection. We're rapidly approaching a day where AI surges into every aspect of our lives. It will run logistics, transportation, drive trucks and cars, create art and stories, answer questions, and act as a personal assistant and therapist and friend. It become our interface to the world and speed up how we make games and movies, how we find information, how information finds us, discover new drugs, new material breakthroughs, so design chips, surge into robots that clean our house, take our dog for a walk. Now, people think AI is not creative. Obviously, never studied any of AlphaGo's games. Like I said, the successor to the model had invented these moves that nobody had ever seen in 2,500 years. That's creativity, and a kind of genius, whether anyone can see it or not. And the critics think our current generation of AI is not going to get anywhere because it's too flawed, and they're absolutely and totally wrong. We've got a ton of room to squeeze from the current ideas, and we are really just getting started. At the beginning of any technological revolution, the technology is messy and doesn't do everything that we want and the way that we want it. And it doesn't matter if it's the steam engine, the car, the vacuum, or the cell phone. The first vacuum cleaners pictured there were huge. They were so huge they needed a horse to pull them. So it's not exactly the perfect device for cleaning your flat. The spoiler alert, they got better. And now we have cordless vacuums that fit in our hands, and all using the same basic principles as the giant horse pulled version from a century before. So that's always what's happening. It starts out messy. It starts out a little not perfect. And then the engineers are working on it. The feedback loop happens. The money pours into it. And all of a sudden it gets better and smarter and faster over time. That is the way of all things. They start out with flaws. The critics always miss that the engineers are working on. They're going to find ways to make it better, find ways around the flaws, make it smaller, faster, lighter. Machine learning is going to get better at driving trucks and designing chips, creating art. AlphaFold created a database of 1 billion protein fold predictions. And as humans, we'd only managed to do 100 million through experimentation and traditional code predictors. Now, are all those perfect? No, but that's still a huge upscale in our capacity and our ability to start there. And it accelerates our ability to do all kinds of things. It's not perfect yet, but perfection is a pointless goal. Imagine that self-driving cars kill 250,000 people on the road every year. Would you accept that? Many perfectionists wouldn't. They'd say, they'd be screaming that the AI is killing us, and it's too dangerous in the real world, that it's got to be stopped now. But what if I told you that humans kill 1.3 million people worldwide every year in driving accidents? 250,000 would be a dramatic drop in the loss of life. That's 1 million people. That's more than 1 million people still playing with their kids, hanging out with their partner, taking a walk in the park. It's an incredible amount of lives saved. So perfection is not the goal. These systems are already going to be safer and smarter than us. So AI is just starting to get good. We're at the foot of the mountain and looking up at an exponential curve. And it doesn't look like much from where we're standing. Tim Urban covers this perfectly in his essay on AI and where it's all going. It looks like, we've kind of started to take off, and then all of a sudden, bam, you have this huge capacity. And that's what we're looking up at now, this massive uptick in complexity, economic activity, brand new jobs, this stupid story that that robots are coming for all the jobs, that most of those articles could have been written by ChatGPT itself. They're just churned out, fear-based nonsense. We're going to have all kinds of brand new, varied jobs. We've always created new jobs. We've destroyed all the jobs in history multiple times. You didn't tan leather or hunt the water buffalo. You didn't tan leather to make your clothes today or hunt the water buffalo for your food. 99% of people used to be involved in agriculture, and now it's 3%. We've created more jobs at every single step. And no, this time is not different. It is absolutely not different. We're going to have new and varied jobs. It's going to be absolutely fantastic. Everyone should just be tremendously excited about it. AI is coming out of the big labs. It's coming out of big tech into the real world. It cannot be stopped. It will not be stopped no matter what people try. And it's industrialization that will push these systems to get safer, smarter, and more aligned with what we want to do. That's the irony. As many folks think we can make these things safe ahead of time, but that's not the way that it works. You have to put things out into the real world and learn from things. OpenAI, for instance, thought that ChatGPT's biggest attack was that people are going to be using it for political disinformation. And it's been all this time trying to stop it from doing that. And then when it got out there, nobody did that. They wasted all their time. But humans were creative in getting it to launch virtual machines and search the web and write spam and all kinds of other things, right? So the only way we can discover these things is putting them out into the real world. We've flipped in a strange way in society where we've kind of, as society's gotten safer, richer, infinite mortality is driven down. It's one of the greatest times to be alive. It's paradoxically made us more afraid of risk, because when you have a bunch of awesome stuff, you don't want to lose it. And so we've gotten to this point where we think, we would never have thought of telling, the kitchen knife manufacturers that they couldn't put out the vegetable knife unless they could guarantee no one ever got stabbed with it. It didn't matter if 99.99999% of the people cut vegetables. They've got to prove that it can't ever be used for anything bad. That's not reality. It's not how it works. We're going to have to put these things out there. People are going to get them. They're going to get smarter and smarter and smarter based on interacting with the real world. Humans are tremendously creative. We're tremendously creative at getting around, doing exploits, finding loopholes. So it takes putting these things out into the real world. We don't need to get to perfect, but we are going to get the AI that's much safer, better, smarter, and faster. And we're going to accelerate it by speeding up AI, not slowing it down, speeding up artificial intelligence and the development, speeding up the industrialization. It's not going to be perfect. It'll never be perfect. That is an impossibility in anything in life. Nobody is perfect. Nothing is perfect. But it is going to be much more consistent, much more often. I told my 86-year-old grandmother that I work in artificial intelligence. And she said, well, what's that? And I tried to explain it for a minute. It was pretty complicated, and she didn't really have a lot of capacity for that kind of stuff. It was just sure beyond her thinking. Brilliant old lady, but just not something she'd ever experienced. It's like trying to describe a tree to someone who had never seen one. And so then I just showed her a self-driving car navigating the busy and chaotic back streets of China, something that many human drivers couldn't do well. There were bikes zooming out, people crossing the road, stopping and starting, people not going the correct direction, dogs starting out into things. It was absolute chaos, and the car was navigating it brilliantly. She said, oh, I would never get in that. And I said to her, Grandma, in 20 years, people will say the exact opposite. They'll say, I'll never get into a car with a person driving because it's just too dangerous. Thank you for your time. I'm Dan Jeffries, Chief Intelligence Officer at Stability AI, Managing Director of the AI Infrastructure Alliance. You can find me on Twitter and LinkedIn, and you can find me on Substack. Just go ahead and just Google Dan Jeffries. Thanks so much for your time. Hope you have an amazing and excellent show. I really appreciated you being here.